We're now going to move to English language example that will rely, however, on a concept of knowledge maps or knowledge graphs that can be applied in multiple different languages or independent of language as such. And to introduce this topic as well as a concrete service or a use case for us is Ruth Pickering, who's co-founder of a company called UNO. Ruth.
Hello, my name's Ruth Pickering, and I'm delighted to be with you here today. I'm actually recording from the West Coast, from Silicon Valley. So what I'd like to talk about is really how artificial intelligence-based tools can help overcome the issues we all face today in terms of information overload. So I'm going to cover in this presentation things like how it can help improve indexing and adding new capabilities that haven't been available in a historic or legacy environment. And I'll also talk a little bit about the fragmentation of content and things like bias and the evolution of language. So in terms of the agenda for my talk, we're going to first of all start looking a little bit at AI technology itself. I'm going to focus on knowledge graphs, which is what we do here at UNO. Then I'm going to explain how you go from taking data or content and transforming that into something that's usable as knowledge. And I'm going to go into the details of really how content is processed. Then I'm going to move on to concepts and disambiguation. It's very interesting that in terms of the terms we use for concepts, 75% of terms have more than one meaning. And I'll come on to some examples of that. Then I'll kind of jump into how it can really help people find exactly what they're looking for, and some examples of visualization and looking at different content types. And then I'll leave you with some opportunities for further reading in terms of papers and patents, and then we'll move into questions. So first of all, looking at knowledge graphs. So this is a very beautiful quote from Leonardo DaVinci. "The acquisition of knowledge is always of use to the intellect, because it may thus drive out useless things and retain the good. For nothing can be loved or hated unless it is first known." And that's the essence of what we're here to talk about today, this huge volume of information that's very fragmented. And actually, until you can assimilate it, you can't actually derive knowledge. So first of all, what is a knowledge graph? So there's no universally accepted definition. So I've got here 5 different definitions, and then I'll come on to a little bit about how we would describe a knowledge graph and how it can be used in terms of the research environment. So essentially, a knowledge graph is something that acquires and integrates information dynamically into a dynamic knowledge base, and then it can apply a reasoner to derive new knowledge. So if you think about any kind of traditional database of information, it may be very good at storing and structuring and organizing what it contains, but it's not deriving anything further. It's not deriving new knowledge or inferences from that data. And what a knowledge graph is able to do is take it to that stage further, and also to be continuously updated. So first of all, at its foundation, a knowledge graph is a graph which encodes semantics, and it can enable the derivation of new knowledge through an inferential reasoning process, and it will evolve with new data. And I think everybody on this call today is aware of how much new data is produced, how frequently in the world we live in today. So I'd like to show you this little video here. So this is just to give us all a sense of how quickly information is changing. So as you look at the graph in front of you, this is a graph, a knowledge graph that's ingested news content, about 10,000 news items a day. And what it's looking at is 2 concepts, tariffs and trade war. And as you can see each of those lines in the video moving, that is how fast the relationships between those concepts and the exposure of those concepts to each other is changing. So clearly, as we can see these lines literally moving in front of our eyes, it's quite clear to us that as researchers, there's actually no way we could possibly have read all of that information ourselves individually and understood the dynamic changes that we see unfold before us in this video. So what I'd like to do now is to explain a little bit about how AI technology can help transform content into knowledge. So what you see here in this slide on the left-hand side is content, all different types and sources and formats of content. It could be journal articles, it could be news, it could be patents, it could be reference sources, it could be books or book chapters, theses and dissertations. And then what's happening in the middle is a deep neural network is being applied. So algorithms are running over the content. And the key thing is that they're reading every single line, every single sentence of the text. They're not just taking the traditional metadata that's been provided in terms of keywords. The algorithms are reading the text, and they're not just reading it and hunting for keywords, they're understanding context. And from that, they're able to identify meaning in the form of concepts and promote those into a knowledge graph that we see on the right-hand side. And the great thing about a knowledge graph is that it's a fantastically flexible mathematical instrument. And so we could all interrogate it with a different query of a different concept and get meaningful results that are always up to date and dynamically kept up to date and correlated with other relevant connections and concepts. So I'd like to go through a detailed example of actually a piece of content being processed by artificial intelligence technology using a knowledge graph. So what you see here is on the left-hand side, content can be ingested into our pipeline. So in this example, I'm going to use a piece of news, but as I said before, it could be any type of unstructured text. So the first thing we do is to take the text and split the text into sections. So here you can see we have 3 sections: snippet index 0, snippet index 1, and snippet index 3. And the key thing about this is that we are splitting the text into sections. And so later on in the research process, you can actually take the researcher or the user to the exact section of the document that they're looking for. So using AI to help find documents is one thing, but you still can have a huge amount of text to sort through. And actually what the technology can do is not only take you to the document, but it can take you to the exact section of text. And then for every single section of text, we perform concept extraction. So you can understand how many concepts are in each section of text. And those things will have what we call a concept ID, a CID. Obviously, they have the name, which is the term that's being used for the concept. And then they will have a pertinence score, which is about their relevance within that document itself. And then this is the exact example of the piece of content and the concepts that have been extracted from that piece of text. And you can see there's a huge range of things. You have things that can be a single word, something like coupon or payment or price. And you can have things that could be a couple of words, like Great Recession or asset allocation. And you can equally have things that may be 3 or 4 words, things like silver as an investment or Chicago Board Options Exchange. And for each of those concepts that's been extracted, we see 3 things. We see the concept ID or CID, we see the concept name, so the term, the word or group of words used to describe that concept, and we see the pertinence score. So this is hugely useful information in terms of helping researchers get to exactly what they're looking for in their research. So now we're going to look at concepts and disambiguation and why a concept-based approach is really important. So a concept is an individual term, a word or group of words that carries with it a significance and also an inference. So if I take this example in front of us here, on the left-hand side, we can see a picture of a jaguar the cat, and we understand that it is an animal. And on the right-hand side, we can see a picture of Jaguar the car, and we can understand that it's an automobile. And then if you look at the 2 pictures, both of those have a description, and both of those fit into a topic hierarchy in different topics and subtopics. So it's clear that the same term Jaguar can be applied to not only these 2 things, but also many other terms we can think of. But they're clearly completely different. And if somebody starts their search for Jaguar, looking for Jaguar the cat, they absolutely wouldn't be interested in finding examples of Jaguar the car in their search results, and vice versa. So understanding or disambiguating the search term you're using is critical in terms of getting the results you're looking for. So how does that work? So As you use AI, because it's reading the full text of the documents, rather than simply taking the keywords that may have been tagged that don't carry with them a definition, the algorithms read the full text, they identify meaning in the form of concepts, and we can see in this example, the term monetary policy has been highlighted in purple and has been extracted, and we can see that it's now called a candidate concept. So using machine learning without human supervision, this can all happen on a huge volume of content at any time, any point in time. And then what that next happens after the concept has been identified and extracted, it goes to a lookup. And so it says, I believe monetary policy is a concept. Let me find a definition. And then here we can see in the final box, the definition. Monetary policy is the process by which the monetary authority of a country controls the supply of money, often targeting an inflation rate or interest rate to ensure price stability and general trust in the currency. So now, if anyone want to find that term in the future, they will understand the exact term because it has a description and a definition. So what is the difference between concepts and keywords? So because a concept carries with it a definition, there could be multiple words to define the same term. So if we think about a term that's been coined recently across Europe, which is Brexit, Brexit actually means the United Kingdom withdrawal from the European Union. So whether you start your search with Brexit or whether you start your search with United Kingdom withdrawal from the European Union, what you're looking for is the same thing. So those two different terms mean the same thing. So a researcher would want to find all of the relevant results, notwithstanding whichever of the terms they use. Equally, on the right-hand side, we have another example, and particularly in science, you find terms and names may change a lot over time. So if I were to start looking for the drug Nurofen, which is actually a brand name, I would actually want to surface everything about ibuprofen, which is the correct name for that drug. So in terms of disambiguation, how does it really help us? So if you started your search looking for the term depression, you could be talking about a geologic depression. You might also be talking about a meteorologic depression or a low pressure area. You could be talking about an economic depression. If you were talking about an economic depression, you might be talking about the Great Depression, the Long Depression, or possibly the Depression of 1920-21. Or you might be talking about depression in the mood, a physiological depression, or equally major depressive disorder. So this slide could carry on for many, many more options around the word depression. But as we can see, the term depression can mean so many different things. And when somebody starts a search, it's very important that we're able to disambiguate so that we can give the correct results. And the other important thing about artificial intelligence technology is that it can understand context and meaning. So as terms have changed over time, so today, for example, we might use the term 3D printing. 3D printing hasn't always been called that. So if you look at these two examples, sections or snippets of content, they don't mention the term 3D printing because they're older. So they use previous terminology, but artificial intelligence technology is able to surface them and provide them to the reader as relevant pieces of text. And again, it's also taking them to the section of the document that's relevant rather than simply to the major kind of title level of the document. So moving on, how can AI help you find what you're looking for? So if we look at a term like belongingness, this is what we might find in a traditional search platform. And here's another example if you put it into an academic search platform. And in each of these two screens, we've got a list of results, but as you walk away, you probably haven't learned anything specific about belongingness. And if we look at this, it's a visualization, how a knowledge graph can help. So we see belongingness in the center, and then all around it, all of these connections, self-esteem, group dynamics, group cohesiveness, immediately we get a sense of the kind of things that relate to belongingness, and we'll begin to get an understanding of that concept, what it's all about, and related terms. So you have this constellation of other concepts, which helps you really understand the context of what you're looking for. So carrying on the theme of visualization, one of the really important things is not just understanding that two things are connected, but understanding how they are connected. And actually, as an individual, reading around that subject and making our own decision about what we believe is correct. So here you have an example on the right of a very controversial subject, autism and the MMR vaccine. And what we can see displayed is those two concepts and a third concept, controversies in autism. So what the knowledge graph is able to do is to ingest these huge volumes of information, and it can present back to the researcher in a visual format the different concepts, and it doesn't make the decision for you as to what is right, but it shows you all of the connections and the relationships. And then the researcher can use that and go to the source information that's been published, read it themselves, and make their own decision as part of the research process. And here's another example that somebody mentioned to me where they had heard about early onset Alzheimer's disease, and they believed that physical exercise might be something that could stop it. So again, you can put those two things into the knowledge graph of visual environment, and it will show you all of the connections, and it will also show you all the links. And so as you see the links, you can click on the concepts, you can click on the connecting lines, and you can get to the source literature to explain those connections, and you can read through and understand how they're related. So in terms of use cases with different content types, you might be interested to understand a portfolio of content and understand how things within that content base have been trending over time. So it could be content that you happen to own, or it could be an open access content set. And this is one example of how we can use artificial intelligence to understand content and also see trends. And again, this is something that would not be possible by a human alone, because you have to read so much content to be able to see the patterns in the content and in the information. But what you can see here is a collection of content that's been analyzed, and then it's broken down by topic. And then on the right-hand side, if you want to drill down and look at some very, very specific concepts and how the amount of content that's been published over time has changed, you can do that. And you can also compare across content collections to see different trends. So moving on now, I'm going to share with you some papers and patents for further reading, and then we'll hand over to questions. So in terms of publications, these slides will be circulated after the presentation. So please do feel free to take a chance to look up these papers. We've included the DOIs for all of them if you're interested in a little bit of further reading around this subject. And I'm also sharing with you here a couple of patents that you might find interesting. So now I'm going to close, and I'm going to hand back to the audience for further questions. And thank you very much for listening.
Thank you, Ruth. This is really fascinating way of approaching, let's say, also the historical development of terminology, and something that we discussed earlier today in a paper around fairness and sort of intergenerational justice of cultural heritage. That in the past we've used different terms to mean or the same things, and meaning of terms also changes over time. And this is a wonderful tool to explore these kinds of developments. I had a fairly sort of detailed question. When you showed us how a new concept is being added to the pool of others, there was a definition of that new term. I wondered where does that come from?
That's a great question. So in terms of definitions, we always use definitions from reference sources. Mm-hmm. And we always provide at least one open access definition, and very often we have multiple definitions. So in terms of the open access sources we use Wikipedia, Mesh, and Investopedia. Mm-hmm. And then additionally, we have Ancient EU and Britannica and OUP reference. So you'll always find at least one open access in case your library doesn't subscribe to some of the licensed sources. But we don't make them up ourselves. And I think that's a really important part about sort of the integrity of the AI and the knowledge graph, is that it has to be a reputable source to be used.
And the sort of technology as it is now, is it something primarily to as a sort of visualization aid for a human interrogator to take then further steps? Or do you see this as a stage in some workflow or process or interface that is followed by some other technology tool that takes this further?
Yeah, it's a really interesting question. So I think when we kind of approached the product, traditional search tools have been around for a really long time. So we've all had access, to a list of things in front of us. And that's going to be around probably forever. And we weren't looking to displace the existing tools. We were looking to add something into the ecosystem that hadn't been possible before using AI technology. And I think there are a couple of critical things that have been lacking historically. So if you think about traditional search, which is based on the available metadata that may be a year old, 20 years old, 100 years old, and the term that's been picked out by the editor or the author at that date may have changed. And maybe for a book, there were only 5 terms. So that item of content will probably never be surfaced because no one's using that term anymore. It's not current. And secondly, there were so few terms. So we wanted to make content more accessible and more discoverable rather than being hidden simply because it may have been indexed badly. And the second thing that wasn't in the sort of traditional environment, the research environment, was really around visualization. So we all know that we're pretty much all visual learners, but as you grow up and as you start reading, obviously you read left to right. Most of the text is in a traditional format, and that's just been what technology could do up to that point. But actually, when you see something visually and you can see those connections, instantly you kind of learn something. You understand the context of what you're looking at, you understand related terms. And one of the things I hear all the time is that students, particularly undergraduate students or younger students, they don't know how to formulate the correct search query because they don't know the terms to use. So when you approach a new subject or a new discipline, of course, as a beginner in that area, you don't have all of the right vocabulary. So what's brilliant about a knowledge graph is that you can use the one term you know, and it will give you this kind of visualization, this constellation of all of the appropriate terms that may be connected. And I think the other thing that I've observed is that it's just much more fun. So when you do a user group and you give people a traditional interface, they will be sitting back in their chairs like this, and they will be just tapping with their finger, scrolling down a page. And we know that I think 93% of people stay on page 1 and 96% of people take the first 3 results. When you give a focus group a visual interface, they will immediately lean forward like this into the screen. And it's not obvious. You cannot select number 1 because it's not ranked like that, because it's in this visual kind of star environment. So it's just taking you from this very passive search to kind of active engagement. And it makes the whole process fun. And, one of the things that when we did early on focus groups, that people said their biggest frustration of research tools was that they spent hours and hours searching and not finding what they're looking for. And it's very frustrating, and you walk away. And so in this way, much more engaging, much more fun, and you can get to exactly what you're after.
Yeah, it's sort of reminding you of the early days of hypertext, when people loved to jump from one link to another and sort of getting lost and away from the first text they started from. And this was so fascinating that it wasn't sequential reading, but you could literally jump from one section to another. And this is also, I imagine, something that would glue people to their screens because it just keeps you going along a path that you can't predict so easily. We have a question if your product supports other languages or only English.
Yep, it's a great question. So the UI itself has a number of different languages, French, Chinese, German, Spanish. And if anybody wants to add a language to the UI, as long as they'll collaborate with us, we don't have people that speak every language in the world, but we're always happy to do that. I know that some countries do have legislation that means the UI has to be in that language. So we're always happy to add further languages there. And in terms of the actual text, the product at the moment has mostly English, but some Chinese and some German. We have been testing over the past several years Google Translate, and we think it gives actually very good results now. And the way our technology works, because it's actually extracting concepts, even if the sentence syntax isn't perfect, the results are still really great. So that's the way we expect things to go in the future in terms of foreign languages. So, we've done kind of all kinds of languages, from Eastern European languages to Asian languages, etc. So, yeah, I think it's very exciting in terms of how that will open up the opportunities.
In terms of input, what sort of text, what format of text does the product expect?
So we can ingest most text, anything, even things like PDFs and OCRs. If you ask me what I would prefer really great XML, but I could send you a page which probably is about 40 different formats. So I think, the cost of digitization is prohibitive, and so people are unlikely to re-digitize. So we will do the best with what exists. But yeah, if anyone is thinking of digitizing their content set, then obviously the best quality XML will give you the best results. So from our perspective, I think the critical thing is really around the volume of text. So if you gave me, for example, 4 words, well, a machine can't tell context from 4 words. You and I might be able to make something out of it as humans because we know what's going on around us. But from a machine point of view, I would say the minimum would be sort of a short paragraph, 3 or 4 sentences would be kind of ideal. And there's no upper limit in length. So it doesn't matter if you have documents that are 800, 1,000, 2,000 pages. From a machine learning point of view, the longer the better. So the only limitation would just be about individual words or very, very short groups of words. Mm-hmm.
Wonderful, yeah. The volume has been a topic, recurring topic during today, that somebody showed how 10,000 books was not sufficient to train an algorithm. In another case, 14,000 images were not quite enough to teach another image recognition algorithm, etc. So it seems that there are areas of artificial intelligence that do require, let's say, larger data sets or really big data in a sort of common speak. But with knowledge graphs, we can start with a smaller sample. There's another question here that I just read as it is. Do you see a problem with using ideas such as algorithms understanding context and meaning, as the process in the machine is, in fact, nothing like we habitually associate with the idea of understanding in living beings? Does it not create confusion about the real capabilities of the algorithm?
It's an interesting question. I mean, there are lots of different algorithms out there, so I can't comment on other people's, but very specifically, we developed our algorithms to recreate a neural network model. So it's not NLP where you're just hunting for keywords and it's all about statistical distribution and things like co-occurrence. So as the algorithms are reading the text, they're doing what we would do as humans. So they're identifying the concepts, the meaning into the form of concepts, and they're promoting those through the process where it's paired with a definition, and then it gets promoted into the knowledge graph close to the correct or similar other concepts. And it's then kept continuously up to date. So I think, people might use their algorithms to do different things, but from our perspective, what we're trying to do is make sure that we give these very precise, disambiguated results, and we help people get to the exact section of the document that they're looking for. So I think in that respect, it works really well. Mm-hmm.
But do you see a danger of, introducing misinformation or perhaps even bias into these concept maps that emerge if we feed only texts that present one, side of the political view, or one side of, let's say, colonial history is a very hot topic nowadays, that we only present concepts that come from one sort of viewpoint of power, war situations, etc. So is there a balance, or is there an inherent risk in depending on the material that we feed into the model?
Yeah, so I think that hinges on 2 things. It hinges on if you want your algorithm to be biased. Absolutely, humans write algorithms and they can do that. From our perspective, our first product, going back to training data sets, we had 40 million items. And so we very specifically are not looking for this to be biased. We're looking to ingest as much content as we can as broad in terms of the different types of content. So whether it's news, whether it's journal articles, books, chapters, dissertations, etc. And I think just the other point about bias is that if you look at older documents, apart from the fact that the terminology or the words we use might have changed, if you look at things like gender discrimination, diversity, equity, inclusion, a lot of the terms that we would now pick up would not have been picked up for historic reasons of bias. So because the algorithms are reading the full text, they will pick out terms and the documents will be found, and they would not have been found if you were using simply the traditional metadata. And I think the other thing about a knowledge graph is it's not a yes or no system. It's not, answering your question and telling you this is right or wrong. What it's doing is it's surfacing the information and giving you that perspective. You then still need to read all of the relevant information and make your own decision.
Yes, the interpretation always stays with the interrogator. Okay, I think we're finished with our time. Thank you, Ruth, for joining us, and even at this early hour for you.
My pleasure. Thank you very much for inviting me.
Thank you.